So it's time to start. Let's start by introducing myself. I'm Aya. I'm the marketing lead at Flowless, and I'll be the facilitator for this webinar. Welcome again in our second webinar, which is AI-powered waterless management for Africa. Today's webinar is being co-hosted by Flawless and GoSoft. And before we start, let me give you a brief introduction for each. Flawless provides an AI-powered solutions and software with all the powerful tools you need to manage your water system, track leaks, and reduce water loss. And GoSoft Integrated Solution is the leading provider of smart solution for water management, including smart water meters, groundwater sensors, and DMA management, founded by an experienced team of Kenya technology and entrepreneurs and engineers. So this webinar would be an exciting session as we dive deep in the African water sector. And before I introduce our two speakers, I would like to cover a few housekeeping topics. So, in today's webinar is being recorded. I'll share a link with you after the webinar. I definitely welcome you to revisit the content yourself and share it with your colleagues. I also invite your comments and questions. Please look at the Q&A chat box on your screen. If you think of a question for the speakers at any point, just type it in there and mention who is it for. And I will either pose it to our speakers at the time or hold it for the Q&A part at the end of our webinar. So I will ask you to stay engaged, use polls, reactions, and the chat to participate. And if you need a tech help, please message our support team in this chat and they will help you. So I'm excited to introduce our speakers for this session. And let's welcome Christine Tentu. And she's the CEO of GoSoft Integrated Solutions. And she is a smart metering specialist with extensive field experience in the African market, particularly in water management in Kenya projects. She is joining us today, bringing her experience and her deep knowledge in smart metering solutions and water management. And so, Christine, I'll leave the stage for you. It's all yours.
Thank you so much, Aya, and good morning, everybody. So I'll be taking you through our experience in smart water metering in the Kenyan market. So my name is Christine, as Aya has said, Christine Tanto, and I am a co-founder and current CEO of GoSoft Integrated Solutions, a company based out of Kenya. We've been around since 2021, and primarily we've been providing smart metering solutions across several public water utilities and private water utilities in the country. So basically, our solution was designed to offer a solution to water service providers who have a number of challenges that many of you may already be aware of. Number one is there's a lot of infrastructure that is obsolete. Much of this infrastructure was implemented in the 1970s and it's never been upgraded. And this actually causes a lot of non-revenue water loss, which the utilities are unable to account for. We have a lot of issues on inaccurate billing and rising customer expectations, which are as a result of inaccuracy of the billings that they receive. So our smart water meters use a technology called NB-IoT, which primarily means we have a SIM card in the meters, and the SIM card is configured to be able to send data to a platform. This allows for daily data to be sent to the platform and for the water utility to be able to have data on a daily basis without having to physically send somebody to the ground to read the meter. This has resulted in improved billing accuracy. We have seen a lot of leaks being detected early through the platform. We have also seen reduced operational costs because now there's the elimination of having to send people to the ground to read meters. And so selecting the right metering solution and the communication technology that works is actually a really a very important aspect of our business.
Christine,
May I ask you to present your presentation in full screen, please? Because it's not showing up
in full screen. Oh, you can't see.
Yeah.
Okay.
Now,
Is that better?
Yeah, please.
Okay. So the types of smart meters that we typically work with are ultrasonic meters, and this is because of the high accuracy of this kind of meters. They use sound waves to measure the flow. There's no moving parts, so there's no risk of inaccurate measurement of soil or debris or other parts that are not water. And this accuracy also is extended to the flow rates of these meters. Then, of course, there's the electromagnetic meters as well that measure flow using magnetic fields, and these are typically very widely adopted. They are cost-effective and they're very reliable. So using ultrasonic meters for us has seen an improvement in the accuracy of readings for the water utilities that we work with. The electromagnetic ones are for the larger pipes or the big bulk meters that typically are at abstraction sites or at the zonal areas. The communication technology that we're using, as I mentioned before, is NB-IoT. So this means that we have to get into a partnership with a mobile network operator, send them configuration for the SIM cards, send these SIM cards to our manufacturers. The SIM cards are embedded onto the meter, and that's how the communication protocols are established to our platform. There's also a different technology, LoRa and LoRaWAN, which use long range and very low power as well. And this is typically used in rural areas where the network may not be optimized, and there may be very little NB-IoT availability in those areas. So utilities can actually now control what kind of technology they use in their environment. Whether for urban, they can use NB-IoT. For rural areas, they can use a different technology. So the decision to use the NB-IoT or LoRa depends on what kind of coverage you're looking for. And this is the typical difference between the two technologies. For NB-IoT, it's excellent. It is on the ground. LoRa is also very good with gateways. For NB-IoT, we need the operator. For the LoRa one, we don't need the network operator. There's quick coverage for NB-IoT. If it exists, it's really quick to implement. The LoRa one needs a bit more setup, but then the utilities can actually control this technology on their own. So NB-IoT can be used in rural areas and in urban areas, and we have seen in our deployments, we have deployed in both urban and rural areas. For LoRa, we can have a mixed terrain, so it's not limited to areas where there's a requirement for network availability. So in terms of choosing the right technology, smart metering isn't one size fits all. So we have to do a survey. Normally, we have to go into an area and check with the network operator whether there's NB-IoT availability, whether it is a rural area or an urban area. And if the NB-IoT network is not available, then what we do is we design what technology we're going to use in that area. If the water utility wants to own the entire deployment, we have the ability to allow them to do that. If they want to have data on an hourly basis, on a daily basis, we have the ability to set those parameters within the meters when we do the installations. Depending on the budget that the utility has, then we can design the meters based on what their budgets are. So typically our meters have a lifespan of the battery life is between 10 to 16 years, but this is dependent on how the configuration of the data transmission happens. In some utilities, you find that they want to have the bulk meter readings twice a day. This means that the battery only works when they're sending the data. So you find utilities that do that, the battery life, of course, reduces from 16 years to probably 8 or 10. If the meter is only reporting once a day, then of course the lifespan of the battery is longer. The batteries, we are able to change the batteries, and within our system, you're able to see the lifespan of the battery and be able to plan ahead as the battery level goes down, and then we can organize for replacements. So the right technology should actually solve the biggest pains for each of the utility companies that we work with. Then there's always an issue about CapEx and OpEx and return on investments. So smart meters require investment. They're not cheap. They're not the typical pricing of the analog meters or other digital meters in the market. So over time, you actually save money, even though you spend a little bit more with the smart meters that we are positioning in the market here. So when we look at the operators that we've worked with to date, a lot of them actually recover the entire cost of the meters within the second billing. Because remember, we are replacing meters that typically are stuck. They are not reading correctly, or probably the meter readers have been reading meters and not recording properly. So either they're estimating, either they're writing, they're recording wrong readings. So when we install our meters, the accuracy is enhanced. So this means that the water utilities actually see an increase in revenue within the first month of installation, and then it kind of like balances out within the first 2 months. But in terms of ROI, they recover their money like really quickly. Then there's also the issue of ROI in leak detection. This also helps the utilities to reduce their non-revenue water, because if they're able to see the leak detection on their platform through the alerts and alarms that we have, then of course they're able to fix those very quickly and reduce the amount of time it would take them otherwise to send somebody physically to look around and find out where the leaks are happening. Remote readings also cuts out the field visits, because then they're saving on fuel, they're saving on personnel and manpower having to go around, reading these meters physically. So the accurate billing also improves their cash flow, because people are able to pay upfront. And in totality, we've seen that some utilities actually see their ROI, recovery within 3 to 6 years. Most of these utilities have actually said they are saving costs in terms of operations. They are increasing their revenues. Their customers are happier. Their staff are happier, because now they don't have to spend 2 weeks reading meters. They're spending less time and more time in maintenance and providing customer support. So to get started, I think what we've done and what has worked for us is we have done pilots. So by doing a pilot, we install a couple of meters in an environment. We choose a simple area whereby we can now measure the specific area and how much non-revenue water has been saved. It can be a rural or a commercial area or a public utility or a private utility. And then we monitor for 3 to 6 months. The reason why we do the pilots for 3 to 6 months is because the first month, of course, we have to take the manual readings from the meter that has been replaced. Then we monitor what the billing is like. The second month, of course, people get settled. Some of the bills go up, some go down, but then it balances out over time. And then we do a lot of training as well for some of the utilities. We also have to analyze the data that they're receiving. We teach them, how do you read the data? How do you interpret the data? How do you analyze the data that you're getting? How do customers respond to this new technology? How is the customer service? So there's a lot of work that goes in during the pilot phases, and immediately the utilities see the impact of the deployment of the pilot, then we get engaged in a larger commercial deployment. We also make sure that we do whatever integrations are required, either for billing within their with their financial systems, and through our end user app as well, that allows consumers to be able to see their consumption on a daily basis. This helps the utility companies to reduce the issues of consumers feeling that they're being cheated on their bills, or they don't have visibility on how much they're consuming, and it makes them a little bit more endeared to the water companies, because now they believe that there's transparency in the bills they're receiving if they have the access to the data. So the roadmap to a successful rollout, number one, is defining the goals. What problems are you looking at? What are your problems today? Is it water loss? Is it billing? Is it visibility of data? Is it customer satisfaction? And once we help you define the goals, then we select the right technology for you. If the technologies that I mentioned before, NB-IoT, LoRaWAN, or other, this comes about during the consultative process, and then we do the surveys. Then we run the pilot program and then validate that. And once it's validated, then we roll out in the areas that we design. Most times we find that for rural utilities, their typical customer base are the commercial customers, because these are the hospitals, the schools, the hotels, churches, and big institutions that actually are high consumers. So we find that those ones are actually key to to the rural water utilities. So then we plan the full rollout in phased deployments. We're starting off with the ones where the NB-IoT network is available readily, whether they're commercial settings, but we get this list from the water utilities and then work with them to plan this rollout. We also train teams. We train the customer care teams. We train the ICT teams. We train the non-revenue water teams. We train the entire team within the utility that is going to be responsible for the different aspects of our solution. Half the time when you find a new technology, you find that it sits within the ICT department. But the technology does not only touch on ICT, it affects and impacts everybody within the organization. So we try and run training and workshops and involve a lot of the teams within the organization. Then we use the data now to monitor and analyze and see what is the consumption pattern of each of the individual consumers. How are they consuming their water? Is there a change from the previous consumptions to current consumptions? How are they adopting to getting their consumption readings? And so we do this all analysis with the water utility, just to ensure that they have an efficient way of managing their distribution and consumption. Of course, there are things that can go wrong. Number one is the high upfront cost. We find that a lot of public water utilities don't have the capex to deploy large replacements. So for this, we have tested a couple of models. One is having a phased rollout, whereby they provide a certain upfront cost, and then we spread the rest over a period of time. And because they are already seeing an increase in their revenues, this model has actually proved to be a better model for them, because they use the increased revenues to pay for the hardware. And then the rest is just on the software, which is paid monthly or annually. Poor signals, we've experienced this in some areas. And this actually is why we insist on doing surveys. So when we do the surveys, then we work with the network operator, they upgrade the network in that area. We continue testing and make sure that the parameters are up to standard. And then we do the integration issues as well. We find a lot of integration issues because most water companies have got a billing partner. They have a different ERP in their system. They have a different financial system. So integrating our system with some of these financial existing platforms can also be tough, because you find the water utilities want to integrate with their existing billing partner, who is actually using analog systems. So we have to work with them to integrate within their financial system, because that's where it's important to them. We also have customer resistance, because most customers don't want to pay for their water, because they believe that water companies actually steal from them, or their readings are not correct. So one of the things that we engage in with water companies is we do joint sensitization of this technology. So we go in with them, we update the customers, we let them know why we are installing these new meters, what the benefit is for them, what they're going to be able to see. And we are seeing that when we engage with them together, then it makes the customers a bit more confident and a bit more comfortable in adopting this new technology. So it's a lot of work, but we have to work with the water utilities as partners and not just as solution providers. So these are some of the challenges I just wanted to highlight. And as we continue engaging with different utilities, we develop new systems, we upgrade our engagement with them, and we ensure that we are providing a service that actually works for the utility within the environment that we have deployed. So this is my presentation, and thank you very much. And I look forward to any questions that you may have if you've posted them on the chat. Thank you very much.
Thank you so much, Christine. And for the audience, if you have a question for Christine, please raise your hand or drop it in the chat box. Okay, since we don't have questions, let's continue this webinar by introducing our second speaker. But first, thank you, Christine, for sharing this valuable information with us today. That's really insightful. Now let's move to Becker. Becker is Flowless co-founder and CEO. and he has been leading the development and expansion of Flowless solution for smarter water loss management. During this webinar, he'll showcase how using AI-powered technology helps you detect and stop losses before they escalate. But before Becker start, I'll share with you a poll that will appear in your screen. Just let me share it with you. Yes, you should be you should see it now in your screen. I encourage you to participate and share your opinion on this question, which is which stage present the greatest challenge for your utility when it comes to managing water loss? Is it awareness and the quantification, identifying score or type losses, planning and intervention, or ROI tracking? Please take 60 seconds to make your selection, and then we will share the results. Becker, while our audience responds to the poll, what would you expect to see?
Based on the experience that we had with many utilities worldwide, I see that the challenges are very different based on the context. And we see that some utilities are already adopting or starting to adopt some sort of smart metering or smart technology, but then they adopt it on a small scale, but then they are struggling to expand it. And that's maybe because of the payback period is too long, or the the initial deployment was not feasible enough for them. So I guess it would be the challenge of when it comes to water loss management. I think it would be very different from one utility to another. But then again, the starting point is, I would not say easy, but it can be easier than the more advanced stages.
So let's see the result. So we have the greatest challenge for most of them is identifying source or the type losses. And the second one is the awareness and quantification. And yes, I agree with them in this regard. So now, Becker, sorry for that.
Should I start sharing my screen?
I'm going to hand the floor for you. So please go ahead.
Okay. And thank you so much again, Christine, for your very insightful presentation. I will be actually building up on Christine's insights and sharing with you some of the case studies that we had and through our work with GoSoft, our joint efforts that we had been doing in East Africa, but also across Africa. And I would be also talking more about the approach, how you can potentially deploy this in your context, and giving you some real life examples of how AI-powered insights and technology can support you in managing the digital transformation journey. Okay, so I'll start with the challenges since you already talked about that, or you shared with us your challenges. Thank you so much for sharing that. I just want to let you know that this is pretty much everyone's challenge. They start with, option one when they are faced with those lots of challenges regarding water losses and efficiency and feasible operations. The first option is in many cases, utilities just don't do nothing, which is, the the most comfortable option, but of course not the most optimal one. And in this case, they would continue to lose a lot of water and a lot of money. Then option two, some of the utilities try to solve the problem, by going to the field, trying to find leaks or trying to replace old meters, but they do it manually, which works, but it takes a long time and sometimes it's not cost efficient. Now, the third option, which many utilities nowadays consider, is utilizing technology. Now, when utilities usually want to adopt technology, they adopt what we call legacy tech solutions, right? And what this means is legacy tech solutions are technologies like SCADA systems, like other types of analysis of technologies that work, but they are not the ideal solution, especially in the era of AI and the new emerging technology that's out there. And the reason I'm saying this, not because this technology is bad, of course, it's a good way to start, but then it only collects data and it only tells you it doesn't tell you what's going on in the field, doesn't help you in detecting the root cause of the problem, which we saw from the poll is one of the biggest challenges that utilities face, not only in Africa, but everywhere. So let's maybe address one of the most problems that we face in legacy tech solutions, which is data silos. And what this means is we see that different departments in the utility, especially if it's a big utility, but also for small utilities using different systems like an ERP system and then a SCADA system and a meter management system. Each one of those systems would be working in their own environment, and they're not integrated with each other, which is a very big problem. And in this case, the utility is losing a huge opportunity because you already have data. So why not bring them all together in one place and let them talk, let the data talk and interact with each other. And from there, you would be realizing a huge amount of really useful insights that support you in managing your network much better. But unfortunately, this doesn't happen all the time. And the reason I'm saying this is because everyone is going after data collection, deploying meters and pressure sensors and data loggers, which is good, but that's not enough. That's the first step. Then afterwards, you have the data integration that we already talked about in the previous slide. Then data analysis, which ideally should be automated because you don't want to use spreadsheets that require you to invest a lot of amount of effort and time to analyze the data. Then step three is intervention planning based on the analysis that you have already done and implementation. So to implement those interventions and track and evaluate the progress along the way. This is the ideal scenario, and it starts from, again, data collection. That's the cornerstone, but then you should continue doing the next steps. And in this presentation today, we will be highlighting a practical way for water utilities, regardless of their capacity, regardless of how big they are, or what technology they have. We would be highlighting a very practical way for utilities to go through this chain of steps until they reach up at a point where they are able to realize tangible impact in terms of water loss reduction, improvements in collection fees, the efficiency of collection, and overall feasibility of the operations. And we say this based on our previous experience working with utilities all over the world. So we worked previously in the Middle East, in Palestine, Jordan, and in Oman. We also have a lot of partners in Africa. I would be highlighting some of them in Mali and in Kenya. And of course, we also have other projects in Brazil and in the US. Now, one of the most insightful experiences that we had previously in Africa is our work with GoSoft and with World WaterNet and Mali. So in Mali, the utility that's serving the whole country, it's called Somajeb. And Somajeb has been having a lot of non-living water challenges. and intermittent water supply as well. It's continuous in some places, but it's intermittent in other places. And of course, the large concern, or the one of the biggest challenges, is data availability. And we supported them in terms of adopting the technology that works best for them. And when I say technology, I'm talking about the basics of data collection, measurement, and data transmission, all the way until we get to the point where we are able to analyze the data and they are able to see the insights and implement them in the field. So that's one of the case studies that we will be highlighting today, and all the steps that you would be saying afterwards, seeing afterwards, would be adopted from the learnings that we had with this case study. And then the other case study is in Kenya with Runda Water. Runda Water is in Nairobi, and again, we've been working with them. We've been working with GoSoft support Runda on doing smart bidding. Very different context, a very different need, but the good thing is when you have a flexible technology and context-aware technology, then you are able to adapt it to the context and use it for your benefit. So what happened there? What happened in Kenya for Runda and in Mali for Samajit? First of all, we did a reality check. So we looked at their everyday operation, right? What they had is a lot of data challenges, fragmented data, siloed. Every department has their own database, and they were not communicating with each other, which is very common not only in Africa but all across. And then, of course, limited coverage for SCADA or any system for data collection, whether that be SCADA or IoT or other solutions. That's also a very common challenge. Then manual processes. This is a huge drain for money and time and efforts. And finally, operational gaps. So we're talking about uncertainties, a lot of data gaps, and intensifying issues like increasing non-revenue water volumes and so on. And this is not to say that they did not try anything before, because they were trying a lot of solutions. They were trying manual, they were trying automation, and they were trying spreadsheets. But then the problem is, it started with a good, nice trial, but then the challenge was expanding this trial from the pilot phase to the wide adoption because of many challenges, because of the budget and because of the technology, because of the readiness of the utility, and many different circumstances in the field. Based on this, we actually introduced an alternative approach that we call anti-pilot. We don't like pilots. And not because pilots are not good, but because pilots can be hard to expand. And our solution for this is adopting an alternative approach where we start with an assessment for the whole the whole system, including the needs, the future strategy, so that we understand the context, not only for the sake of deploying the pilot, but also for the sake of integrating the expansion strategy as part of the initial deployment. This means that when we are deploying the pilot or the initial implementation in a small DMA or in a small zone, we are taking into consideration how we can potentially expand this together with the utility. Then, of course, we deliver the value. We support the utility along the value chain from getting the smart devices, installing them in the field, and until we reach a point where we are able to analyze the data and support the utility to act upon them. Finally, continuous support to make sure that the team is able to understand the insights and act upon them. How this looks like in the field. So one of the frameworks that we deploy for water loss management, we call it loss lifecycle management. And it's a life cycle because it starts at one point, which is awareness. Awareness means simply that you are able to spot issues like leaks or non-living water problems or metering issues as soon as they emerge, not after 1 month or 2 months or even after 1 year. So early awareness or early detection of those issues is critical. Then identifying the type or the root cause of the issues. Is it a leak or is it something else? Because in many cases, utility would be focusing too much on leaks, but maybe they would have, you would have more, I would say, easier ways to reduce non-living water, like replacing your consumer meters if they are very old. So this step is super critical for you to be able to identify which intervention is more feasible and more impactful. Then step three is quantifying each types of those losses, locating them where they are happening. Step four, and then prioritizing them as we discussed previously, and finally taking action and evaluating along the way. And the cycle goes on and on because it's a continuous process. I would pause here for a moment and ask Aya to share our next poll with you to try to find out where, yeah, I would not spoil the fun. So let's look at the poll. Um, do you use smart tools for losses management? And how long or how much do you go through the process of deploying them? Is it only on the pilot stage, or do you use them regularly on a daily basis? Do you just, discover them, try to discover the options, never adopted them, or you're not sure? So. And please, if you have any comments, maybe you have a previous experience, maybe you're not happy with previous technologies, maybe you don't believe in technologies, or you think AI is a vibe and it doesn't work for the water sector, please let us know. We would love to hear from you. So drop it in the chat or simply unmute yourself. We would love for this to be a very interactive session, and I would love to pause for a moment and hear your comments if you have any. So I see more votes are coming for the poll. And again, if you have any thoughts or experience to share with us, please feel free to drop them in the chat.
Okay. I think we are ready to show the results.
Yes. Okay. Very nice. So it looks like many of the participants are exploring the options, which is good, and it shows a lot of interest. I would be curious to know what you have explored so far, and what options are you taking into consideration. This would be very insightful and very nice to hear about. Okay, so okay, talking about the next step, which is okay, we talked about the approach, what happens, and how we can utilize or how we can think about deploying technology in different ways. Let's see how this technology works after we deployed it, how it worked for Mali and for Kenya, and what results they were able to achieve. First of all, we have to realize that not all utilities have similar needs. Some of the utilities, like for example, Rwanda needed to start with smart billing because this was their highest, this was their number one need. But for other utilities, for Mali, they wanted a solution for non-living water management. And throughout our work, we really customize the deployment to fit the needs. So we have our system, Flowless platform, divided into modules. And each one of those modules, we deploy them based on the requirements and based on the scope of work and based on the understanding of the context. You can ask for one of them or all of them. And the last one I would also love to highlight, which is facilities management. If you are still managing your pumps and valves manually, then it would be very exciting for you to consider to automate them in one way or another. But we will be covering this in a moment. And to make this even more usable for utilities, because we've seen that when we deploy the technology, sometimes the utility have junior employees, or even the senior employees don't have enough capacity or time to go over all the charts, and because everyone provides charts, right? SCADA systems, they all have nice charts and nice visualizations, but then what happens after that? What do we do with those charts? And we've seen this a lot, and we've seen that utilities don't just need a chart or a table with data. They need something tangible to tell them where the problem is, how big it is, and how they can potentially fix it. And to facilitate this, we introduced an AI agent, a chatbot that you can literally talk to. So here in this presentation, I'm asking it to find leaks in a specific zone. It brings in the most relevant piece of insight, like this chart over here. Then it explains it or in plain English. It tells me what this chart is saying, what this means for me, and how I can fix it. And by utilizing this type of technology, the utilities that we worked with before, they were able to move from pilots to actual impact, and from raw data to insightful interventions and action plans. And of course, it's backed by advanced analytics. So this is not like ChatGPT. This is not a generic AI agent. It's connected with your context, with your data that's being collected from the field, and it provides the insights based on this data analysis and then explains it in plain English, as we said. But then again, the dilemma here, or the overwhelming problem, is how to adopt this technology and how to bring it to your context in a realistic way, because we don't live in a rosy world. We know that everyone has a lot of challenges. So how to overcome them? We do this by going throughout a comprehensive implementation process, going through 5 steps essentially, and each one of those steps has different ins and outs. But step one is building on what you already have. So the starting phase is looking at the data that you already collect. Maybe you have some meters at the production sites, or maybe you have the billing data, the GIS. This is a very good starting point, and we start from there, and then we build based on it, and based on the discussions that we would have with you. Then context-aware analysis, based on the data that you already collect. Maybe we would be able to also deploy some more meters with support from GoSoft, and then based on it, we would be getting those analytics and insights. Then advanced analysis from the data, moving from data to actionable insights based on the approach that we have provided previously. Then providing training and active knowledge transfer to make sure that the knowledge is not ours, it's transferable to your team, and they are able to utilize it on a daily basis and understand what this chart is saying, how to interact with the platform, what does the KPIs for tracking non-living water mean, and how I can utilize them on my daily operations to guide my strategy and my implementation plan. This is a cornerstone of the approach overall. Yeah, so again, it starts with looking at your network, doing a survey, looking at the meters that you already have, and understanding the context. Then based on it, maybe we would need some more data collection points for pressure or for flow. Mainly we use flow at the inlets and the outlets, in addition to inlets and outlets of the zone or the MA, and then the pressure at the average zone pressure point. Based on it, you would start getting a holistic overview of what's happening in your network. So how much you have in terms of leaks, in terms of apparent losses, and different types of those losses, and where they're happening, and how you can potentially fix them. So it's again a stepwise approach, and to summarize, it starts with component analysis through the water balance. This is the very first step based on the data that we have already collected. Then quantifying the water losses. So, for example, Somajib and Mali, they were able to quantify how much they have in terms of leaks and other types of losses. Then planning, doing simulations for how effective pressure management is, or should they be doing pressure management or actively control, and based on it, doing some scenario analysis, prioritizing the most impactful intervention, and finally, impact evaluation to make sure that we are on track to achieving our targets. If this makes sense, and if you think that this can be adopted in your network, then this is a quick overview of what can be done in your network, right? The first step is assessment. It usually takes between 2 to 4 weeks, depending on how ready you are and depending on the data readiness. So in this phase, we would be asking for data, some checks on the DMA boundaries, and also field surveys. Then we would move to the next step, which is a quick analysis throughout Flowless platform and the smart telemetry or smart metering from GoSoft, 3 to 5 DMAs, then measuring the impact and the ROI, and finally expanding, which should be going fast if we have the right momentum and the right support. And speaking of the right support and momentum, let's join forces to make sure that this approach is converted into reality in your system. Please feel free to reach out. You have my email, you have Aya's email, and of course, Christine. And we would be happy to schedule one-on-ones to explore your needs and explore how we can move forward together. Thank you so much. I would pause here. If you have any questions, please feel free to drop them in the chat or unmute yourself and ask the question, and we would be happy to interact with you.
Thanks, Becker, for all the insightful information you've shared with us. They are really good and a practical guide for any utility to start their non-revenue water reduction journey. And as Becker said, we've come now to the Q&A session. If you have a question, please enter in the Q&A or the chat box, or raise your hand. Simply unmute yourself and ask directly. And don't forget to mention who is the question for Becker or for Christine.
We would also be happy to hear about your experience. If you would like to share with us your previous experience trying to reduce water losses in your network, what tools you used before, which approaches do you use, and so on. We would love to hear from you. Anyone want to share their experience?
Or maybe have question about smart metering or
Yep.
AI tools.
Christina, are you still with us? Because I have a question for you.
Yes, I'm here.
Okay, very good. So one of the questions that I had in mind while I was preparing this is, and you touched upon that, right? So you talked about that technology is not cheap. It can be more costly, especially looking at the capex. So how do you usually deal with this when you have one of the utilities in Kenya or Tanzania interested in the technology, but they don't have enough resources to afford the technology? What do you do?
Thanks, Bakar. So I think this is a typically common question that we face with many utilities. And as I mentioned before, because the technology is not cheap, we design models, financing models through our financing partners. Local banks have come through in some cases whereby they design a model that is a lease to own. So we buy the meters through the financing facility provided by the banks, and then the utility, because they already have a base incremental revenue. So we use that, they use that to repay back the hardware part of the project. So we've done this in Kenya. We've done it with one utility where they, it's a lease to own model. So they pay us a little amount every month. And that doesn't impact the revenue increase that they have, because if they increase their revenues by, say, $10,000 and they're paying us $2,000 every month, it's not a big deal. So we're able to pay back the banks and we're able to keep our money. Once that repayment has been done for the hardware, they're only left with now the software payments, which they make on a monthly basis or on an annual basis. So this model, because it's been very attractive and it's working very well with a public utility, it's working very well with a private landlord, we are extending the same to a new project that we are embarking on in Tanzania. So we involve the financial institutions as well, and that actually also has been very helpful for us.
Thank you so much, Christina, and that's that's giving me hope, because I always tell the utilities that financing for me is not the most challenging part, and technology is even sometimes not the most challenging part. The most challenging part is having the commitment and the ownership, because whenever you have the tool, technology is just a tool, and you can have different ways of financing it through different modalities and different financing vehicles. But then again, if you have them in the field, how to utilize them properly to achieve real life impact. And maybe we can touch upon that briefly, but I see a question in the chat from Jim. Thank you so much, Jim, for raising this very important question about detecting illegal use, whether that be agriculture or some other types of illegal use. This is a challenge that we see everywhere, and it's very hard to spot illegal use unless you have the proper type of data collection and data analysis technology. So previously, we've seen a lot of issues in this regard, and if you have monthly billing data or monthly consumption data, then sometimes you are able to spot some issues, especially if they are large issues. But if you have more frequent data collection, like every day or even every hour, then you are able to see spot problems. One of the issues one of the cases that we have saw in the past is simply because you have flat rate of consumption, but you know that this facility or this property is it has an activity. So why they're not using water? Why is the meter reading 0? This indicates that maybe the meter is malfunctioned, so you need to replace it, or it might indicate that there is some bypass or illegal use. This is one of the simple interventions, but there is also more advanced analysis through different types of algorithms to detect anomalies in the consumption. If the consumption is going up and down in a very non-justifiable way, then this is another red flag that you can use to do or to direct the field surveys for illegal use detection. Yeah, this is what comes to my mind for now. But yeah, I would acknowledge that it's a challenging problem, but if you have the tools and the technology in place, it would make your life much easier and would give you visibility to direct your team in the field for field work. I see Margaret raised her hand. Please go ahead, Margaret.
Yeah, I think mine is more of an observation and feedback as well. Recently, we did an AI kind of survey to look at utilities' willingness to adopt and some of the things that they'd be looking at addressing. And I think it comes at a time where utilities in Kenya, I feel, have really shied away from adoption because, one, they really don't know how to go about it. But two, there's also, I think I've seen Kevin also raise a question of, what type of infrastructure do utilities need to have to actually start adopting these systems. And I think part of the things that utilities are still struggling with is, of course, NRW management and how to use data that is coming from their billing system to actually make informed decision. And I think this conversation comes at a really good time. So maybe the question that I have again is feeding into what Kevin has. What maturity level does a utility need to be at to actually adopt AI when it comes to resolving some of the challenges that they already have? Because we have utilities that are still using manual system to collect data. And what does that journey look like for such kinds of utilities, which is common in Kenya?
That's a very good insight, and thank you so much for raising the question, Margaret. I would like to share some insight from what we have seen before with the utilities in Kenya and across Africa. But I would also be curious to understand or to learn about the results of the survey that you did. Basically, in our work, we always tell the utility that you don't really need to go fancy from step one, right? Because AI sounds colorful, it sounds nice, but in many cases, this is not the first step. And the first step can be even much easier to adopt. And when we say AI can be many different things as well. So it can be leak localization, it can be anomalies detection, or it can be utilizing generative AI, like we saw the chatbot or the AI agent. So the AI agent can be readily adopted without, having a lot of field data collection points or whatever. We've worked previously with utilities that just have the bulk metering data collection and the pressure sensor at one or two locations in the network. And through that, they were able to utilize the AI agent to interact with the data and understand it and make it available for their team in the field. So yeah, it depends on what do we mean by AI and which stage of maturity we are at. And again, we don't need to go all the way until the top level of maturity. Maybe we can start small and then expand based on that. This is the core of the approach that we have presented in this presentation. Thanks, Margaret. Please keep asking those questions. I see one question in the chat for Christine. Aya, do you want to go ahead and?
It's from Hillary, and I think it's about the governmental regulations. And the question says, how do you deal with the government institutions like WRA when it comes to standards in the smart meters? There was supplier tenders last time I checked for water abstraction meters that I haven't seen if they implemented. I observed so many uncertainties with WRA when it comes to this smart metering technologies. Christine, the question is for you.
Thanks for this question. So typically, when we embark on a smart metering project, we work with utilities that are already regulated by WRA and WASREB. So while we provide the solution to the utilities in terms of the hardware, the access to dashboards, end user apps, and billing, we ensure that they already have the compliance with WRA and WASREB on their end. So we have experienced engagement with one utility that was not compliant with all the regulations required, and we had to pause because while we had done a pilot, we needed to extend that pilot to an additional maybe 400 meters from the 10 meters that we had deployed. But there were some regulatory issues that they were still not completely compliant with. So we had to take a pause. And this pause has been a 1-year pause until they get all those regulations and compliance documentations completed. So we typically work with regulated water service providers. We do not, if they don't have all the regulations, then we don't engage.
Okay, as we come to the end of our session, I would like to thank everyone who joined us for today's webinar. Christine and Becker, thank you so much for sharing your great insights and valuable experiences. And for the rest, if you have any additional questions or would like to connect directly with Flawless or GoSoft team, you can either reach out directly using the contact information I drop in the chat, or you can reach via LinkedIn. Thanks again for your time and have a great rest of your day. Bye-bye.